What's up? What's up? Today we're talking about introduction to radical expressions. So I'm going to teach it in the light of your next course. And with that being said, I want to keep it simple as if it was for your course, but a little bit into next year as well. So you may see something like, let's say 2 cube root of 4x, okay? So essentially what you're gonna see is, let's call that blue, and that would be considered, to me, outside the house. Not hose. House. Okay. And then, let me do this here. This is called, I'll move this as we go here. All right, and this right here is a house, and then we are going to lasso this here and make this orange, and this orange will be inside the house. Okay, so essentially that radical sign, okay, so this is what I call the radical sign. Okay, so the radical sign is what I call the house. So the orange is inside the house while the blue, the 2, is outside the house. The 3 that's in green, that's going to be in this wedge here, is called the index or the root, and I call this in the wedge. Okay, so that's essentially the parts of a radical sign. Okay, so for this semester, in your wedge, you're not going to see a number. So if no number, it's a 2, okay? So when you see just a sign like this, it means that the index can't spell. The index or the root is a 2, okay? Because you don't see anything in that wedge. And what we call this is a square root, okay? So that's as far as you're gonna go this semester, but next semester you're gonna go into where in that wedge could be a 3, could be a 4, could be a 5, and so on. And the same rules apply to that. Okay, so what happens when the root is a 2? So what it's looking for is pairs of numbers. Okay, so it's looking for pairs. In fact, I should say this, pair or pairs, all right? And what else was I going to say? I'll leave it as that. They're looking for pairs of numbers or groups of 2, okay? So notice that and that is the same, okay? So if in that wedge was a 3, then we're looking for either triplets or groups of 3. And the reason why I put that group of 2 in there is because when it gets to 4, I could say quadruplets, and then I don't know what 5 would be. So that's why I have to put down or the groups of 2. So what do I mean by that? So for example, if I say, hey, what is the square root of 25? Well, if I was to break 25 down, so most of my lessons so far is about breaking numbers down, right? So if I was to break this down, what you will see is that it'll be the square root of 5 times 5. Those two are both prime numbers, so I can't break them down anymore. So since I have a pair of 5s, so this is kind of like, back in grade school when it's recess time and they say, well, if you can find a partner, so you have a pair, you can go out to the playground and play. However, if you don't have a pair, then you're going to have to stay in the classroom because I don't want you to run away or not be able to ask where you went to, where you gone. So since they have a pair, that means the square root of 25 is actually going to equal to just 5, okay? Or you can say square root of 25 is 5 because 5 times 5 equals 25. But either way you look at it, since they have a pair, they can go out to play. And if that's the only pair, then that means there's nobody else left inside the house. So therefore the house is no longer needed, okay? So another example. Let's say it's the square root of negative 25, okay? So this, it can't be found because I can't find a pair of numbers, right? 2 numbers multiplied together to give me negative 25. I can do negative 5 and positive 5, right? If I do negative 5 and positive 5, they're not the same, okay? So that can't be a pair, right? So since I can't find those 2 numbers, then this is going to be not... Let me just keep it at caps here. Not a real number. Now, eventually, you will figure out what it means by not a real number because it would take non-real numbers in order to find the square root of negative 25, okay? So, let's see here. Now, you could have examples that are going to, or problems that are going to be in words. So they might say, hey, find the square root of 9. Okay, so in the way this is phrased, that means that this is going to be the square, you're looking for square root of 9. So, well, that is the square root of 3 times 3, and that is a pair, so therefore the answer is 3. Okay, so they might also ask you, hey, find the negative square root of 9, okay? So what this is saying is, notice how the square root is all together behind negative. The negative is in front. So the negative square root of 9 means it's a negative. Here, let me do this so you guys can see. Let's make that red so that I'll show the negative, okay? And then I will lasso this right here, turn that to blue so that this is the square root of 9. So that's the literal translation of what was above. So in this case, this is going to equal to a negative 3 because the square root of 9, in fact, let me do it even better. Let's do this. So the square root of 9 is 3. The negative is applied after the fact. So now this is my answer, okay? Because the negative is on the outside. Now up here, notice how the negative is on the inside. If the negative is on the inside, then I can't take the square root of it because I can't find a pair of numbers that are exactly the same to get negative 25, okay? All right, so what's the other way they can phrase it? Find the square root of negative 9. Okay? So if that's the case, notice how the square root, the house, is built over the negative 9, right? So let me do this. That's negative. Okay? And then the square root, oops. Let's see, that's going to stay as a blue. But if you notice that the negative is attached to the 9. So that means I have the square root of negative 9. Okay? So in this case, my answer would be not a real number. Okay? So that would be my answer there. Okay? So those are some of the things that they might ask you. So let's take some examples that are what you're going to actually see as well, that are not just words or not as simple as just a square root of 25. Okay? So let's say example of this. Let's say I'm looking for the square root of 36x squared. Okay? So if I was to break it down, I want to break down the number, I want to break down the x squares. Okay? So this is going to be the square root of 2 times 2 times 3 times 3. Okay? That's 36. It's going to be, if you did your factor tree, okay, so let me put it out here. 36, it'll be 6 times 6, 2 times 3, 2 times 3. So it'll be 2 times 2 times 3 times 3. So that's what I did there. And then x squared is going to be x times x. Okay? So if you notice, what do I have? I have a pair of 2's. I have a pair of 3's. And I have a pair of x's. So I have 3 groups that can come out to play, and nobody's left inside the house. So that means my answer is going to be the 2 comes out, the 3 comes out, and the x comes out. Nobody's left inside the house, so I don't have to draw that house anymore. So I don't have to draw this radical sign anymore, okay? So I don't need that anymore because nobody's inside the house. So therefore, this is going to be 6x. 2 times 3 is 6, and then the x. Okay? All right. So what if we have something like this? Okay? So my question to you is, what is the power attached to? Is attached to the 38D. So essentially what I have here is the square root of 38D times 38D, right? So look at this. I have a pair of 38s, and I also have a pair of D's, right? So they both come out. So I got 38 comes out and D comes out. Nobody's left inside the house. So that would be my answer, okay? Make sense? Hopefully. All right. And you might see something like this. You're going to have a squared minus 16a plus 64. Uh-oh. I've seen those before, right? Those are trinomials that I need a factor, right? Those are quadratics. So you're going to have to go and do the AC method. So you're going to take this right here. I want to take this, change it to orange, and bring it over here and say, okay, I have A times C, which is equal to 64. B is equal to negative 16. So my two numbers must be negative 8 and negative 8, because negative 8 times negative 8 gives me positive 64. Negative 8 plus negative 8 gives me negative 16. Okay, so I'm going to have A squared minus 8A minus 8A plus 64. Break it down the center. My GCF in the first group is A, leaving me with A minus 8. My GCF in the second group, since the third term is negative, I'm going to pull a negative and an 8. And I'm left with A minus 8. Okay, so my answer is going to be A minus 8 times A minus 8. Ooh, look, they are the same thing, right? So that means I can write this as A minus 8 squared. All right, so that means I could come back here and say this is the square root of A minus 8 squared. Well, what does that mean? That means I have the square root of A minus 8 times A minus 8. And look at this. I have a pair of A minus 8, a pair of A minus 8. I'm sorry, a pair of A minus 8s. So that comes out of the house. Nobody else is left inside the house. So I'm left with just A minus 8. That's my answer. Okay. Essentially, the square root of a squared of anything is going to be just itself. So in other words, if I say the square root of 2 squared, that's going to be 2. If I say the square root of x squared, that's going to be x. If I say the square root of b squared, it's just going to be b. Okay. If I say the square root of a block squared is going to be just the block. Okay. So basically any square root of anything squared is just going to be itself, meaning that the square root and the squared are actually opposite operations of each other. Okay. So that is kind of my jingle as I throw my pen to the floor. And I hope that this helps. If there's any questions, please let me know. Again, the square root, if there's no number in the index, right? If there's no number here in the index, it's assumed to be a 2, which means I'm looking for pairs, okay? I'm looking for pairs. That's why the square root of 9 is 3, because there's a pair of 3 that can come out, right? Over here, I broke down 36. There's a pair of 2, pair of 3, pair of x's that all 3 of them come out. Nobody left inside the house. So that's why it's 6x, which is 2 times 3 times x. Here is a pair of 38Ds. So the 38D comes out. Nobody else is left. In other words, there's nothing else that is not highlighted in there. So, but if I'm given a trinomial or 4 terms or maybe even 2 terms, I can break them down and maybe I'll have a pair of them. If I have a pair of them, perfect. It will just come out and no house. Okay? Hopefully this helps. Let me know if you need any help.